So here is our bonus problem, and so let's work through this to make sure that we're all on the same page. And so now we have this problem where we're mixing a finite amount of HCl and BaOH, and we want to know what the final temperature is going to be for this particular chemical reaction. So again, we're mixing two solutions, so we can assume that we're going to be in a coffee cup calorimeter. And in this case here, we have Q equals MC delta T for that. Now, the big problem is that we have this energy and it's delta H, but we can't just quite simply plug it in here, right? That would be bad. We can't do that because we're not mixing together 2 moles of HCl or 1 mole of BaOH, and so we're not going to get that much energy. So we have to figure out what that Q is going to be first, and since we have a finite amount of both reactants. And so to do that, it's going to be pretty simple, right? We're just going to say, okay, well, we have let me change the pen. We have 0.1 liter. We multiply that by 0.50 moles for every 1 liter. And again, that's going to be my HCl. Now for HCl, we know that we're going to get 118 kilojoules of energy for every 2 moles of HCl that's reacted. And that comes from the balance equation up here. And so when we do that, we see that if all that HCl were to react, we can get 2.95 kilojoules of energy out. And it's going to be negative because it's exothermic, and we'll talk about that in a second. Now, if we react all the BaOH, again, in this case, we're reacting 0.3 liters, right? But now we're only reacting 1.0 moles of that BaOH2 for every 1 liter. And in this case here, right, we get out 118 kilojoules of energy, but now it's only for every 1 mole of BaOH2 according to the balanced equation. So when we do that out, we're going to get out 354 kilojoules. And so what we see here is that when the reaction stops, because all the HCl would be used up, we're only going to be able to generate that much energy. So, because that's the limiting reactant, and so this is going to be the amount of energy that we need to use. Now, a couple things, right? Q must be in joules, and the reason why it must be in joules is because the specific heat of water is also in joules. So we need to go ahead and convert this into joules, right? Multiply by 1,000, 2950. Notice I lost the negative sign. I'm losing the negative sign just because the negative sign is just telling me if it's endothermic or exothermic. It's going to make your life a lot easier. So we don't need it for this. In this case here, now we know what Q is. So Q is going to be 2950 joules. That's going to be equal to mass. We have 400 grams. And we have our specific heat. And now we can calculate our delta T. And so for this, we see delta T is going to be equal to 1.76 degrees C. And so, again, it was asking us for the final temp. So in order to find the final temp, we know that we started at 25 degrees C. Since this is an exothermic reaction, we would expect the temperature to go up, so we're going to add that. And so since we add it, we see that our final temperature is going to be at 26.8 degrees C. So that's how we would work that one. Again, it's a limiting reactant problem, so we have to take it into consideration. Let me know if you have any questions. Talk to you later.